Hey there everyone, all the techies and data enthusiasts there. Welcome back to my YouTube channel. So guys, this is video 3 of our RAG series, 25 types of RAG series. In this particular video, we will be discussing about corrective RAG, which is nothing but if you know already that the standard RAG, the previous video, if you have not checked that, check it out. In that RAG, what it happens, whatever documents is processed and whatever information is in your knowledge base, it will retrieve it and provide you the answer. But here what it happens in corrective RAG, so here the framework, it's a next level framework which iteratively improves the precision and quality of the response based on the responses it received. It checks in loop and it iteratively improves itself and provides a perfect answer to you. So we will discuss about this in detail. So guys, I have started this series recently, and before this I have done a complete Transformers playlist, and also Django generative AI using Django series is right now still going on. You will get multiple videos related to data science and AI in my YouTube channel. I'm requesting you all to please do like, share and subscribe the channel, and do share this video in your LinkedIn post and make sure you tag me. I will definitely react to your posts. Let us build the community together. So guys, now let's dive into my computer screen and discuss more about corrective RAG. So let's get started. Okay, so guys, here I have a notebook here. As usual, you will be getting this resource in this video link description. So I use this notebook to explain you better. You have all the information here, and parallelly the code implementation will be there. So you all can better understand. That's the reason I don't go with PPTs. I normally go with this kind of notebooks with written documents. Okay. So understanding corrective RAG. Corrective RAG goes beyond simple document retrieval process by evaluation and correction layer. Here what it simply happens in normal RAG, what it does, whatever the answer is, whether it is wrong or right, when it's retrieved it will provide you the answer. But here what it happens, when the answer has been received, the model will check, the LLM model will first check or evaluate itself and correct if the answer is wrong, then it provides to the end user that particular response. So here what it happens, giving a wrong answer is reduced, not completely, but at least if there is some errors in that particular answer, if there is some hallucination, it can auto correct itself, correct and provide you the better response. So key features: knowledge refinement, decomposes document into smaller parts, evaluate accurately and filter ambiguous or incorrect information. Okay, and knowledge searching, for ambiguous or incorrect results, corrective RAG rewrites the query and uses external resource to retrieve better information. And finally evaluates and generate the correct answer. Here what it happens, whatever data is provided, it is been like split into smaller parts. Then knowledge searching is done. If there is any ambiguous or incorrect results, corrective RAG rewrites the question, so it will change the way of writing the question and it will again try to ask. Based on that you get the answer. So here you can see the process: input query, a query submits and a document retriever process is done, fetched. Then correct, retains and you retain and use correct document, and ambiguous request more specific information. Incorrect, if it is incorrect, rewrite the query and retrieves the better result, then the final response is given to you. So here is an image for you all to explain a better. So let me just take this image to my OneNote and I'll explain you clearly. Okay, so I added that particular image to my OneNote here. So let me start with my explanation. So first here, if you see, input question is asked. So normally the standard RAG process is already done. Actually, whatever data need to be uploaded to your knowledge base, that process will automatically be done. I'll show you that in coding. Here just understand how the answer is being retrieved based on the query. Okay, how the workflow or the architectural workflow of corrective RAG works. Okay. So first what here happens is, input data has been sent. Okay, so okay, just give me a second. Okay. So this is your input data or input question. Question is asked. It's not data actually, it's question. Input question is asked, then you submit the query. So the query is been submitted. Okay, the query is been submitted here. So okay, then document retrieval process is started. So we submit the query to document retriever. Then the document retriever will fetch the answer based on cosine similarity. Okay, so based on cosine similarity, it fetches the relevant answer. Then here what it happens, we add a special layer called knowledge correction. So what this layer does, it will send answers to both ambiguous response and incorrect response. Knowledge evaluation, what we do, we gather the data from here and we send it to both. So if the answer is incorrect based on the question results whatever we got, here the query rewriting process will happen, and the rewrite query and retry. So the query which is written, that is again resent to the document chunks. It will retrieve the answer again and provide the output here. Still, if the answer is somewhat ambiguous and suspicious, that answer might not be right. If knowledge correction feels that, it immediately sends to ambiguous check as well. So here, if in this ambiguous check, what it does, if it feels that answer is not right, it will request for more specific information on that topic and again refine query retry. So we again rewrite the query properly and send it to document retriever. Once based on the input question we gave and the answer, both if it feels correct, then only the answer is sent to correct and retain accurate answer. Then finally the combined validation knowledge, so based on that the validation knowledge, it combines the answer and we get the final response here, your output. This is how it works. Here simply we just added one layer here. This can be your layer. So we added this layer so that it can be this both layers and this correction, this knowledge correction layer, so that it can check if there is any error. We can try to solve the error using this method. Okay, using this knowledge correction method. I hope you all understood this clearly. From now onwards, I'll try to use the white pen actually, white color. So I see that the color was not clear, right? Green color. So I'll use the white color from now onwards. You can understand it better. Okay. So guys, I hope you got this. Now let's move back to our practical implementation. So simply just same way, just you can connect your notebook to your IPNB collab notebook. Okay. So just connect this. Once this is done, next run. So when you run, okay, PyPDF has been installed, then you will get the Grok to install. Let us install both of these libraries first. Grok is 100% required. So previously I told in the video how can you create an API. If you don't know, just go open a Grok account, create your account. You will have multiple open source models available here. You can see all the models out here. Then just go to this API keys section. So create an API key, give it a name, copy the API key, and you can use it anywhere. So don't use mine, it's actually obviously free. Once this section is done, I'll discard the API key, but make sure to use your own API keys. Okay, we can actually do this RAG part using LangChain or Llama Index framework as well. But I don't want to show you that. Everyone will show you with using a simple LangChain framework or Llama Index framework. But I want you to actually show what internally the retriever process is going on. Without a LangChain and without Llama Index also we can work on this. That's why I'm going to use simple sklearn PyPDF to reader or retriever. If you want to use LangChain, just search for LangChain self-rag. You will immediately get the documentation on it, whether it can be any rag. So you can see immediately, you can see the documentation, self rag or crag, which is nothing but corrective rag. So we are actually right now working on corrective rag only, crag. So you can see here. So accept this. Now you can start to read here. You can see what it happens and what exactly works here and how the model does. This is self-RAG, and the this particular architecture is of self-RAG. When we go to self-RAG, I'll explain you this. So this is how you can normally directly use LangChain. You can see a simply use from LangChain import hub, string output parser, so LLM prompt, everything you can give here easily and you can complete it. But let us now use this one only. Okay, so I'll install this and I'll run this normal paths here. Then step 0 is the client, so add this. Step 1 we'll be using again same BERT paper, because I'm not doing a production level project or end-to-end anything. You can use any paper, I'm just using BERT paper, that's all. Okay, now what we are doing, we are just getting the data out, so we are writing it as a PDF path, PDF file, read binary. You can see here this is the BERT paper. Then what we do, we just read it, and the chunks again we have 1000 here. We can modify it to 200 or 150, anything of your choice. So I'll just give 150. The more you give, the lesser your chunks are. The model can understand more accurately, but same time the the processing time will increase. Remember that. Okay, it might be only 2 pages, but you can see here 427 chunks we got. 2 to 4 pages must be there in BERT paper. See here, again we are going to use TF-IDF vectorizer only for this. Then retriever relevance chunk for querying. So we have the query what is BERT, and query embedding vectorizer.transform. We are transforming the query. Similarity, cosine similarity we are using. We are providing query embedding and embeddings and chunk embedding, and we are flattening it. We are retrieving the top 3 relevant chunk of information. Top chunk indices, which is nothing but similarity org sort, and we gave this particular format here, top k, and we are retrieving it from last. Okay, finally retrieve the chunk and you get you just wrote a simple list comprehension logic here, for loop. Okay, so this is list comprehension logic. Those who don't know this small list comprehension way of writing, I hope you have to revise your Python again. I already create videos on it, so you can check it out. Next, corrective validation of retrieved chunk. Validation chunk, we have created a variable here. Then in try and except block, we started to write the code here. Try, so you are a fact checking assistant, and the validation doc of the chunk should be there, and feedback response based on that validation. And based on that we again append and rewrite the query. When we run it, you can see a chunk 1 validation feedback. The document appears to be a brief, exact or a snippet from a large document, but it does not accurately address BERT, bidirectional representation of transformers in a pre-trained language model. Okay. Validation 2, the document appears to be a table comparing the performance of different BERT models in various tasks. Query what is BERT is an information seeking. So about the query here, the document appears to be a research paper on academic article and discuss the intake, and it discusses technical terms like BERT and downstream task data. So this is actually you can see a chunk 3 determined to be incorrect or ignored. So this is not that clear. Then again what we do, we finally recheck and provide the validated response here. BERT stands for bidirectional encoder representation of transformer. It's a language model developed by Google that is trained on large corpus of text to understand and generate human-like language. So see the response here and see the response of final generation. You will see how much variation it is. Here it used to just take out the chunks, and there it doesn't have a clear information. Whatever answer was there, it directly retrieved and gave it to you. But when we gave the validation chunk to this, and again when we tried to rewrite the query and ask in better way, you can see at the final response how it looks like. When you have this knowledge correction, CRAG, in CRAG if you have this knowledge correction layer out, so it will maximum try to remove the scrap and provide only the important information. understand this about corrective RAG or CRAG. So I hope this particular video is very interesting to you all. Let us connect again on our next particular video on RAGs. Meet you all in my next video. Make sure you do like, share and subscribe the channel, and do share this video with your friends on LinkedIn. Do subscribe. Meet you all again in my next video. Bye bye everyone.